Human aging feels like a single journey, but it is not. Inside one body, time moves at different speeds. The heart may stiffen while the brain still adapts. Skin may thin while emotional memory grows heavier. Evolution did not design humans to age evenly because it never needed to. Natural selection cared about survival up to reproduction, not balance in old age. What we experience as uneven aging may be the visible cost of how our species first survived danger, hunger, and loss. If the human body was never meant to age as one whole, the idea that aging is one single process is comforting, but it is not accurate. From the very beginning, the human body was never organized around one internal clock. It was assembled from many systems that evolved at different times, under different pressures, and for different purposes. Bones, muscles, skin, blood vessels, and the brain each follow their own biological timelines. They repair damage differently, respond to stress differently, and decline at different speeds. When we say a person is aging, we are using one word to describe many quiet processes that were never synchronized in the first place. This unevenness is not something that appears late in life. It is present from early adulthood, long before it becomes visible. Even in young humans, some tissues are already losing regenerative capacity, while others remain resilient. This pattern traces back to the earliest stages of human evolution, when survival depended on short-term function rather than long-term harmony. Early humans did not need a body that aged evenly. They needed bodies that could hunt, flee, heal wounds, and reproduce under harsh and unpredictable conditions. Natural selection favored traits that worked when they were needed most, not traits that stayed balanced across decades. As a result, different parts of the body were shaped with different priorities. Muscle tissue, for example, evolved to respond quickly to use and disuse, growing stronger with activity and shrinking without it. Bone adapted to mechanical load, but repaired slowly. Skin served as a flexible barrier, constantly renewed but easily damaged. None of these systems were designed to wait for the others. They operate independently, following rules written long before long lifespans were common. This fragmented design becomes more obvious as time passes. When repair mechanisms weaken, the differences between tissues widen. One system may still cope while another falls behind. This is why aging does not arrive all at once. It arrives unevenly, revealing the separate histories embedded inside the body. Looking back to early humans helps explain why this separation exists. Few individuals lived long enough for slow-developing imbalances to matter. There was little evolutionary pressure to coordinate aging across systems because those later years rarely influenced survival or reproduction. The body was built to function well enough for long enough, not to decline gracefully as a whole. What we experience today as uneven aging is the result of living far beyond the conditions under which the body was shaped. Modern humans carry ancient biology into extended lifespans, exposing differences that were once hidden by early death. Aging, in this sense, is not a failure of the body. It is the body continuing to follow instructions written for a very different world. Each tissue obeys its own limits, its own repair rules, and its own rate of decline. The unevenness feels personal, but it is deeply historical. It reflects the layered construction of the human organism, shaped piece by survival needs rather than long-term balance. To understand why aging feels fragmented, we must first accept that the human body was never one unified aging system. It was always a collection of parts moving through time at their own pace. If aging were governed by one central command, the body would decline in a predictable and unified way. But human biology does not work like that. Each system inside the body maintains itself through local rules, not global coordination. Cells divide when signaled by their immediate environment. Repair begins where damage is detected, not where balance is desired. Over time, these local decisions accumulate, producing different aging trajectories within the same organism. This decentralized structure has deep evolutionary roots. Early human bodies were shaped under constant pressure from injury, infection, hunger, and movement. Survival depended on whether a specific system could respond fast enough in a specific moment. There was no advantage in synchronizing the long-term fate of all tissues. What mattered was whether muscles could generate force when chasing or escaping, whether skin could close a wound quickly, whether blood could clot, and whether the brain could learn from danger. Each system evolved to solve its own problem efficiently, even if that efficiency came at the cost of long-term coordination. Over generations, this led to a body composed of semi-independent maintenance systems. Some tissues invested heavily in rapid turnover. Others invested in stability. Muscle fibers respond to use by rebuilding, but only as long as the signaling pathways remain intact. Bone remodels slowly, conserving strength but resisting change. Neurons, especially in the brain, prioritize preserving connections over replacement because rebuilding networks would erase learned behavior. These strategies made sense in a world where lifespan was uncertain and often short. They allowed early humans to adapt quickly to immediate threats, but they also guaranteed that aging would never be uniform. As time extends beyond the evolutionary expectation, the costs of this design become visible. Systems that rely on frequent repair begin to falter when repair signals weaken. Systems that resist change become brittle. The differences between them grow wider with age. This widening is not random. It reflects how each tissue was historically valued by survival. Parts that were essential early in life were given more robust maintenance for that period, not for later decades. Once reproduction was likely completed, natural selection largely stopped caring about coordination between systems. The body was never updated for long-term harmony because there was no consistent evolutionary reward for doing so. We experience uneven aging because we are asking a system designed for short-term success to perform over long spans of time. The body continues to follow its original logic. It maintains what it can, where it can, and for as long as the local rules allow. There is no master plan adjusting the pace so that all parts decline together. What feels like imbalance is simply the exposure of an old design operating beyond its original limits. Understanding this removes the idea that uneven aging is a mistake unique to the individual. It is a shared biological inheritance. The human body ages unevenly because it was never meant to do otherwise. It was built from parts that learned to survive independently, long before anyone imagined growing old as a whole. The uneven structure of human aging becomes clearer when we consider what evolution did not select for. Natural selection does not plan for comfort, symmetry, or fairness across time. It responds only to whether traits increase the chance of survival and reproduction in a given environment. Once those conditions are met, the long-term fate of the body becomes largely irrelevant from an evolutionary perspective. This is why the human organism carries no internal guarantee that all systems will decline together. Coordination across decades offered no consistent advantage to early humans. As long as critical functions worked during the years when survival and reproduction mattered most, the rest was invisible to selection. This absence of pressure shaped the final layer of the body's design. Aging was left unmanaged as a unified process, because there was no reason to manage it. Different tissues were allowed to follow different trajectories without penalty. This helps explain why some parts of the body seem to resist aging longer than others. The brain, for example, retains adaptability through experience and learning because early humans depended on memory, pattern recognition, and social knowledge to survive. Preserving neural connections offered immediate advantages, even if it made the brain vulnerable later. In contrast, connective tissues such as cartilage or certain muscle fibers were useful early but not essential to preserve indefinitely. Once damaged or worn, they were rarely replaced at the same quality. These differences were not mistakes. They were acceptable trade-offs in a world where few lived long enough to feel their full impact. Uneven aging is therefore not a breakdown of order. but the absence of an order that never existed. The body does not fall out of balance over time. It simply reveals that balance was never its organizing principle. Each system continues to obey rules shaped by ancient needs. When lifespan expands beyond those needs, the seams begin to show. Modern humans often interpret this as decline happening too fast or too unevenly. But from a biological perspective, nothing has gone wrong. The body is behaving exactly as it was shaped to behave. The discomfort comes from a mismatch between ancient design and modern longevity. Early humans did not need bodies that aged gracefully over many decades. They needed bodies that worked reliably in the short term, under pressure, uncertainty, and loss. The uneven aging we experience today is the quiet evidence of that history. It reminds us that the human body is not a timeless machine, but a layered solution to old problems. Understanding this does not stop aging, but it reframes it. It is the body continuing to follow ancient instructions in a world that now allows us to live far beyond them. Natural selection is often described as a force that perfects organisms over time, but this description is misleading. Evolution does not aim for balance or completeness. It favors whatever works well enough, early enough. In the case of humans, this meant selecting traits that increase the chance of surviving childhood, reaching adulthood, and producing offspring. Once those goals were met, the future condition of the body mattered very little. This priority shaped how different systems within the human body were maintained. Some were protected intensely during early life, while others were allowed to deteriorate once their immediate usefulness declined. Uneven aging begins here, not as a flaw, but as a direct outcome of evolutionary priorities. Injury, infection, and starvation were constant threats. Under these conditions, the value of a trait was measured by whether it helped in the near term. Strong muscles mattered when climbing, carrying, or escaping. Quick wound healing mattered when survival depended on avoiding infection. Sharp perception and learning mattered when remembering food sources or social alliances could mean the difference between life and death. Evolution invested heavily in systems that delivered these benefits early. It did not invest equally in preserving those systems indefinitely. Long-term balance offered no advantage when few individuals survived into old age. As a result, the body developed an uneven maintenance strategy. Energy and resources were allocated where they paid off quickly. Systems that contributed to early survival were supported robustly during youth and early adulthood. Others were maintained just enough to function when needed, then left to decline. This pattern is visible across the body. Reproductive systems, for example, are highly regulated and well supported until reproduction is likely complete, after which their maintenance changes sharply. Immune responses are aggressive early in life, prioritizing rapid defense, even if that same aggression later contributes to chronic inflammation. They reflect the logic of a system optimized for short-term success. When humans began living longer, this logic did not change. The body did not receive an update. It continued to follow the same rules, allocating care unevenly across systems based on priorities set long ago. This is why aging feels uneven rather than gradual and synchronized. Some systems decline early because their evolutionary job is done. Others persist because they remain useful longer. The imbalance grows not because the body is failing, but because it is revealing the original trade-offs embedded in its design. To understand uneven aging, we must let go of the idea that evolution intended humans to age well. Evolution intended humans to survive just long enough. Everything beyond that is borrowed time, lived inside a body shaped for a very different horizon. The uneven maintenance of the human body becomes more visible when we consider how energy is distributed across life. Energy is limited, and evolution treats it as a resource that must be spent where returns are highest. In early human environments, energy spent on growth, strength, immunity, and reproduction produced immediate benefits. energy spent on preserving tissues far into old age did not. As a result, the body evolved mechanisms that favor early investment and gradual withdrawal. This withdrawal does not happen all at once. It occurs at different times in different systems, depending on when their evolutionary value begins to decline. This creates a staggered pattern of aging that feels uneven from the inside. During childhood and early adulthood, many systems receive strong support. Growth hormones, repair pathways, and immune responses are active and responsive. As reproductive maturity is reached, priorities subtly shift. Energy is redirected toward maintaining function rather than building reserves. Over time, even maintenance becomes selective. Systems that no longer contribute directly to survival or reproduction lose priority. This shift is gradual and uneven because the body has no reason to coordinate it. Each system responds to its own signals of use, stress, and damage. When those signals change, so does investment. Consider how the immune system changes with age. Early in life, aggressive immune responses are beneficial. They reduce the risk of dying from infection before reproduction. Later, that same aggressiveness becomes costly, contributing to chronic inflammation and tissue damage. Evolution tolerates this cost because it appears after the period that matters most for passing genes on. Similarly, muscle tissue responds strongly to activity when strength is crucial for survival. As physical demands decrease or as repair signaling weakens, muscle maintenance declines rapidly. Other tissues, such as certain neural circuits, are preserved longer because experience and memory continue to provide value across much of life. This uneven timing is not accidental. It reflects the fact that different systems pay for themselves at different stages. Evolution does not smooth these transitions. It allows them to occur independently. The result is a body that sheds investment in layers rather than as a whole. Modern humans often interpret this as malfunction or premature decline, but from an evolutionary standpoint, the body is simply reallocating resources according to an old script. The discomfort arises because human lifespan has expanded far beyond the time frame for which this script was written. What once happened near the end of life now unfolds slowly over decades. Uneven aging is therefore the visible trail of energy decisions made long ago. Each system ages when it becomes too expensive to maintain relative to its evolutionary benefit. There is no central authority preventing this divergence. The body does not ask whether the overall experience feels balanced. It only follows local rules shaped by ancestral survival. Understanding this reframes uneven aging as a process of gradual disinvestment rather than sudden breakdown. The body is not failing randomly. It is reducing support where support was never guaranteed to last. Another way to see the logic of uneven aging is to look at what happens when systems succeed too well early on. Traits that offer strong advantages in youth are often kept, even if they carry hidden costs later. Evolution has no mechanism to remove those costs if they appear after reproduction. This creates a body that performs impressively when young, but pays for that performance unevenly with time. The very mechanisms that protect and strengthen us early in life can accelerate decline in specific tissues later on. This trade-off is built into the biology, not added by circumstance. For early humans, rapid growth, strong inflammatory responses, and efficient stress reactions increase the chance of surviving a dangerous environment. These systems were selected because they worked fast and forcefully. However, speed and force come at a price. Rapid cell division increases wear on cellular repair systems. Strong immune reactions raise the risk of long-term tissue damage. Stress responses that mobilize energy quickly can, over decades, strain blood vessels, metabolism, and connective tissue. None of this mattered to evolution as long as these effects appeared late. The uneven aging we experience is partly the delayed cost of early success. Different systems pay that cost at different times. Tissues that relied heavily on rapid turnover or intense signaling begin to show damage sooner. Others, built around stability and conservation, decline more slowly. This creates the familiar pattern where strength fades before memory, or joints deteriorate, while certain cognitive abilities remain intact. The body is not inconsistent. It is expressing the long-term consequences of short-term advantages. Early humans benefited from bodies that could respond aggressively to immediate threats. They did not benefit from bodies that aged evenly over long spans of time. As lifespan increased, the delayed costs of those aggressive systems became impossible to ignore. What feels like imbalance is the separation of benefits and costs across time. Evolution placed the benefits early and allowed the costs to arrive whenever they would. There was no penalty for that delay. Modern humans now live in the space where those costs accumulate slowly and unevenly. Aging reveals which systems were pushed hardest in youth and which were spared. This perspective challenges the idea that the body is breaking down unfairly. It suggests instead that the body is revealing the full price of survival strategies that once worked extremely well. Uneven aging is the historical record of those strategies, written into tissues that were never meant to last equally long. The body does not collapse all at once because it was never built to rise all at once. It was assembled through compromises, and it ages by uncovering them, one system at a time. When we look closely at the human body, uneven aging becomes easiest to understand at the level of tissues. Each tissue type operates on its own biological clock, governed by how often it renews itself and how much damage it is expected to tolerate. Some tissues are built for constant turnover, others are built for endurance. This difference alone is enough to create uneven aging, even before lifestyle or environment play any role. From early human history, tissues were shaped according to the risks they faced and the functions they served. Skin, for example, evolved as a flexible and replaceable barrier. It is constantly exposed to injury, friction, and infection. This rapid turnover keeps the barrier functional, but also makes it vulnerable to accumulated damage over time. The very process that allows skin to heal fast in youth contributes to thinning and fragility later. Bone tissue followed a different path. Bones needed to be strong enough to support movement, carrying, and impact, but they did not need to change rapidly. Bone remodeling is slow and energy-intensive. It prioritizes stability over speed. In early life, this works well. Bones grow dense where stress is applied. But slow remodeling means that once damage accumulates or density declines, recovery is limited. This is why skeletal aging often appears later, but progresses steadily once it begins. Muscle tissue sits somewhere in between. Muscles evolved to respond directly to use. In early humans, regular physical demand signaled muscles to stay strong. When activity was high, muscle repair and growth were maintained. When activity dropped, muscle mass declined. This responsiveness was efficient in a world where movement was essential for survival. It conserved energy when strength was not immediately needed. However, this design means that muscle aging is highly sensitive to changes in activity and signaling. Decline can begin relatively early if those signals weaken, even while other tissues remain stable. The nervous system represents yet another clock. Many neurons are not regularly replaced at all. Instead, they are maintained through repair of connections rather than renewal of cells. This preserves learned behavior and memory, which were critical for survival in social groups. The cost of this strategy is that damage accumulates slowly and is difficult to reverse. Cognitive changes often appear later, but when they do, recovery is limited. These differences are not random. They reflect how each tissue balanced speed, strength, and efficiency in the environment where humans evolved. Uneven aging is the visible result of these separate clocks drifting further apart over time. Each tissue continues to follow rules that once made sense on their own. Living longer simply allows us to notice how different those rules always were. Beyond differences in turnover, tissues also age unevenly because they experience stress in very different ways. Stress, in a biological sense, is not just emotional pressure. It includes mechanical force, chemical exposure, inflammation, and metabolic demand. Each tissue evolved to handle a specific pattern of stress, not all forms equally. Over time, these patterns shape how and when decline appears. In early human life, physical stress was constant but varied. Walking long distances placed repeated load on joints and bones. Carrying tools or food strained muscles and connective tissue. Exposure to sunlight, wind, and abrasion challenged the skin daily. At the same time, internal organs faced metabolic stress from irregular food supply and infection. Evolution responded by tailoring each tissue to its most frequent challenges. This specialization improved short-term survival, but guaranteed uneven aging later. Joints and cartilage, for example, were designed to absorb shock and allow movement, not to regenerate easily. Cartilage has limited blood supply, which reduces its ability to repair damage. In youth, this is not a problem because damage accumulates slowly and movement remains efficient. Over decades, however, repeated mechanical stress leaves marks that cannot be fully erased. This is why joint aging often feels abrupt when it becomes noticeable, even though the process began much earlier. Blood vessels face a different form of stress. They must stretch and contract constantly, responding to changes in pressure and activity. Early in life, elastic vessel walls handle this easily. Over time, repeated strain alters their structure. Stiffening occurs gradually, influenced by metabolic byproducts and inflammatory signaling. This process follows its own timeline, independent of muscle strength or bone density. Meanwhile, the liver and other metabolic organs evolved to be highly resilient. They encounter toxins and fluctuations regularly and developed strong regenerative capacity. This allows them to maintain function for a long time, often outlasting other systems. However, even this resilience has limits, and decline eventually appears when regenerative signals weaken. The nervous system again stands apart. Neurons experience relatively low mechanical stress but high metabolic demand. They rely on stable internal conditions and consistent energy supply. This makes them sensitive to long-term changes in circulation and metabolism, rather than immediate physical damage. As a result, neural aging often lags behind visible physical decline, reinforcing the sense that different parts of the body are aging out of sync. These patterns are not accidents of modern life. They are the continuation of stress response strategies shaped in early human environments. Each tissue learned to survive its most common threats efficiently. None learned to coordinate its aging with the rest of the body. When lifespan extends, these differences become pronounced. Uneven aging emerges as the sum of specialized responses meeting long time spans they were never designed to face. Uneven aging at the tissue level also reflects how repair itself changes with time. Repair is not a constant ability. It depends on signals that weaken gradually and differently across the body. In early life, damage triggers strong responses. Cells divide, resources are mobilized, and structure is restored with reasonable accuracy. As years pass, those signals become less reliable. Importantly, this decline does not occur everywhere at once. Each tissue relies on its own repair pathways, shaped by how often repair was needed during human evolution. Where repair was critical early, it remained robust for longer. Where damage was tolerable or slow to accumulate, repair was limited from the beginning. These structures evolved to transmit force efficiently, not to regenerate quickly. In early humans, a torn tendon often meant death, not long-term recovery. There was little evolutionary benefit in investing heavily in perfect repair. As a result, these tissues heal slowly and often incompletely. Over time, small injuries accumulate, and repair becomes less effective. revealing a gradual but persistent decline. In contrast, tissues involved in barrier defense, like skin and the lining of the gut, evolved with strong repair mechanisms because damage was frequent and survivable. These tissues continue renewing themselves for much of life. However, constant repair increases the risk of error. With age, renewal remains active, but precision decreases. The result is tissue that still replaces itself but loses structural integrity. This is why some tissues appear active yet fragile at the same time. The repair process itself becomes uneven. The endocrine system adds another layer. Hormonal signals coordinate repair and maintenance across tissues, but these signals change with age. Declines in certain hormones do not affect all tissues equally. Some tissues are highly sensitive to hormonal changes, while others rely more on local cues. This difference further separates aging timelines. One system may lose support early, while another continues largely unaffected. Again, this pattern reflects evolutionary priorities. Hormones were optimized to regulate growth and reproduction, not to maintain uniform repair across old age. When their levels shift, the effects ripple unevenly through the body. The result is a patchwork of repair capacities, each fading according to its own history. From the outside, this looks like inconsistency. From the inside, it is coherence following ancient rules. The body repairs what it was trained to repair, for as long as those signals remain strong. Where repair was never essential for early survival, it declines quietly and early. Uneven aging is therefore not only about damage. It is about uneven repair, shaped by evolutionary necessity. Living longer exposes these differences because time stretches the gap between what the body can still fix and what it can no longer restore. The brain does not age in the same way as the rest of the body, and this difference is central to understanding why human aging feels so uneven. Unlike many tissues, the brain was shaped to preserve information rather than replace its basic structure. Early humans depended heavily on memory, learning, and social awareness to survive. Knowing where food was found, who could be trusted, and how danger behaved across seasons offered enormous survival advantages. Because of this, the brain evolved to protect its internal networks for as long as possible. Neurons were not designed to be replaced frequently, because replacing them would erase the knowledge stored in their connections. This choice alone placed the brain on a very different aging path from muscles, skin, or bone. In early life, this strategy works extremely well. Neural circuits strengthen with use. Learning refines behavior without rebuilding the underlying structure. The brain becomes more efficient as experience accumulates. From an evolutionary perspective, this is ideal. It allows an individual to become more competent over time without paying the energetic cost of constant regeneration. However, this design also means that when damage accumulates, repair options are limited. The brain prioritizes stability over renewal. It preserves what exists rather than starting again. As long as damage is slow and mild, this approach maintains function remarkably well. This is why many cognitive abilities can remain intact even as the body weakens. Physical aging becomes visible earlier because those tissues were built to tolerate replacement and loss. The brain hides its aging because it resists change. But this resistance comes with trade-offs. Metabolic stress, reduced blood flow, and accumulated molecular damage gradually affect neural function. Because neurons are not easily replaced, small changes compound quietly over time. The result is not a smooth decline, but a delayed one. Cognitive changes often appear later than physical ones, reinforcing the sense that the brain and body are aging on different schedules. This separation has deep roots. Early humans who retained memory and judgment longer had an advantage within social groups, even if their physical strength declined. Elders could guide, warn, and teach. Selection favored brains that stayed functional beyond peak physical performance. there was less pressure to keep muscles or joints equally resilient. As a result, the brain's aging curve was stretched, while other systems followed steeper paths. Modern humans live long enough to notice this gap clearly. We experience bodies that slow down while minds still reflect, adapt, and remember. This is not an accident of modern medicine. It is the continuation of an ancient division of labor between body and brain. The brain was allowed to age differently because its value extended beyond physical strength. Uneven aging, in this sense, is not just biological imbalance. It is evidence of how human survival shifted from pure physical endurance toward knowledge, memory, and social continuity. While the brain preserves information longer than many other tissues, it does not escape aging. It simply ages according to different pressures. To understand this unevenness, it helps to look at how the brain is supported rather than how it is built. The brain is one of the most energy-demanding organs in the human body. Even at rest, it consumes a large share of available energy. In early human environments, this investment made sense. A brain that could anticipate danger, plan movement, and navigate social relationships paid for itself repeatedly. Evolution, therefore, protected the brain's access to energy and blood flow more carefully than many other systems. This protection allowed neural function to persist even as the body began to slow. However, this protection was never absolute. It depended on systems outside the brain itself. Blood vessels, metabolism, and immune balance all influence neural health. These supporting systems age along their own timelines. As they change, the brain feels the effects indirectly. Reduced elasticity in blood vessels alters circulation. Metabolic shifts affect glucose availability. Low-level inflammation interferes with signaling. This creates a delayed vulnerability. For many years, the brain appears resilient. Cognitive function remains stable, while physical signs of aging become more obvious. Over time, however, small disruptions accumulate. Because neurons are preserved rather than replaced, their performance depends on the stability of the environment around them. When that environment degrades unevenly, brain aging accelerates in specific ways. Memory may remain strong while processing speed slows. Emotional regulation may change while language remains intact. These selective shifts reinforce the sense that the brain does not age as a single unit either. Within the brain itself, different regions follow different clocks. Areas involved in basic sensory processing often remain functional longer, while regions responsible for complex integration are more sensitive to long-term stress. This internal unevenness reflects how different cognitive functions were valued across human evolution. Skills that supported immediate survival were protected strongly. Others, useful but not essential, were allowed more flexibility. The result is a brain that ages unevenly within itself, just as the body does. Modern humans often interpret these changes as sudden or alarming, but they are the outcome of long-term dependencies finally becoming visible. The brain does not suddenly fail. It gradually loses the support systems it relied on for stability. The brain's delayed decline is not a promise of permanence. It is a reflection of how long evolution expected the rest of the body to keep up. The uneven aging of the brain also reveals something deeper about how humans adapted socially over time. Early human survival did not depend on physical ability alone. It depended on shared knowledge. Groups that retained memory across generations could recognize patterns in weather, migration, and danger. Older individuals, even when physically weaker, remained valuable because they carried experience that younger members did not yet possess. This social role shaped how the brain was allowed to age. Selection favored neural systems that could remain functional beyond peak physical performance, even if other parts of the body declined. The brain did not need to stay fast or flexible in every way. It needed to stay reliable in the ways that mattered most for social continuity. This distinction helps explain why certain cognitive abilities age more slowly than others. Skills related to accumulated knowledge, emotional understanding, and social judgment often persist longer than raw processing speed or sensory acuity. From an evolutionary standpoint, this makes sense. Quick reaction time mattered most in youth, when physical survival was at stake. Wisdom, pattern recognition, and emotional regulation mattered later, when individuals contributed by guiding rather than acting. The brain's uneven aging mirrors this shift in function. It preserves what remains useful while allowing other capacities to fade. This internal prioritization creates a brain that does not decline uniformly. It changes shape rather than simply losing ability. Modern humans often experience this as contradiction. The body weakens, but insight deepens. Memory for distant events remains vivid, while short-term recall becomes less reliable. These patterns are not random. They reflect how the brain redistributed its resources across the lifespan in response to social roles that emerged long before modern life. Importantly, this unevenness was never meant to be experienced in isolation. In early human groups, physical limitations were shared. Knowledge was pooled. Aging brains operated within supportive networks. Today, individuals often face aging alone, making these changes feel like personal failure rather than expected transition. The biology has not changed, but the social context has. The brain continues to age according to ancient expectations, preserving certain functions while releasing others. Uneven aging, in this light, is not just a biological process. It is a social artifact carried inside the nervous system. The brain ages differently because it evolved to serve the group, not to remain uniformly capable in isolation. Understanding this prepares us to look beyond the brain itself in the next truk, where uneven aging emerges not just from internal design, but from the mismatch between ancient bodies and modern environments. Modern life did not create uneven aging, but it exposes it more clearly than any environment before. The human body was shaped for a world of movement, scarcity, and constant adjustment. Food was unpredictable, physical effort was unavoidable, and rest followed exhaustion naturally. Under those conditions, the uneven design of the body remained mostly hidden. Life often ended before long-term imbalances could fully emerge. Today, that protective curtain is gone. Humans live long enough and with enough stability for the differences between systems to become obvious. What once unfolded quietly near the end of life now stretches across decades. The body's ancient structure meets an environment it was never prepared for. This mismatch does not change the rules of aging, but it magnifies their effects. Systems that evolved to respond to regular physical stress now face long periods of inactivity. Muscles that once received constant signals to repair and strengthen lose those signals early. Bones that adapted to load remodel less efficiently when load is absent. Meanwhile, energy intake becomes steady rather than episodic, altering metabolic signaling in ways that affect blood vessels and connective tissue differently. These changes do not age the body evenly. They accelerate decline where ancient assumptions are violated and leave other systems relatively untouched. The result feels inconsistent, but it follows a clear logic rooted in evolutionary history. The nervous system provides another example. Early humans faced immediate, tangible stressors. Stress responses were sharp and brief, followed by resolution. In modern life, stress becomes chronic and abstract. Hormonal signals remain elevated for long periods, subtly affecting tissues that were never designed for constant exposure. Blood pressure regulation, immune balance, and metabolic control drift out of alignment at different rates. The brain adapts behaviorally, but the body absorbs the physiological cost unevenly. This further separates aging timelines across systems. Importantly, modern medicine does not eliminate this unevenness. It often prolongs life by supporting specific systems more effectively than others. Cardiovascular health may be maintained while joints deteriorate. Longevity increases, but synchronization does not. This reveals a deeper truth. The human body does not possess a built-in mechanism to harmonize aging under extended lifespan. It continues to operate according to rules shaped when longevity was rare. Modern life simply removes the constraints that once kept those rules from becoming visible. Uneven aging, in this context, is not a sign that modern humans are aging incorrectly. It is evidence that we are living beyond the range our biology expected. The body responds faithfully, but without coordination. Each system follows its own ancient logic into a future it was never designed to reach. One of the most revealing aspects of modern uneven aging is how daily patterns fragment signals that once aligned naturally. Early humans lived by cycles imposed by environment. Activity rose with daylight and necessity. Rest followed exhaustion. Food intake fluctuated with availability. These rhythms synchronized many systems indirectly. Muscles, metabolism, hormones, and sleep followed a shared structure shaped by survival. In modern life, these synchronizing forces weaken or disappear. Artificial light extends activity into the night. Food is constantly available. Physical effort is optional rather than required. Each system receives mixed signals, and they respond independently, according to their own thresholds. Over time, this deepens the unevenness already built into the body. When sleep becomes irregular, its effects are not distributed evenly. Cognitive performance may remain stable for a time, while immune balance shifts. Metabolic regulation may suffer before memory does. The brain adapts behaviorally, but the body absorbs the physiological consequences unevenly. This is not because sleep loss targets specific tissues deliberately, but because those tissues differ in sensitivity and repair timing. The result is aging that feels scattered rather than unified. Nutrition follows a similar pattern. The human body evolved under conditions of scarcity and variability. Metabolic systems learn to store energy efficiently and release it during shortage. In a constant surplus, those systems behave as designed, but the context has changed. Fat storage remains efficient. Blood sugar regulation strains over time. Blood vessels respond differently than muscles or nerves. Some tissues adapt, others accumulate damage. The imbalance widens not because the body is confused, but because its responses are tuned to conditions that no longer exist. Technology further separates aging timelines. Tools reduce physical demand, protecting joints and muscles from immediate wear, but also removing signals that maintain strength and coordination. Cognitive load increases while physical load decreases. The brain is challenged in new ways, while the body is spared in others. Each system adapts locally. No mechanism ensures they age together. Medical support amplifies this effect. Treating one system successfully allows others to continue aging unchecked. Pain relief may preserve mobility while masking joint damage. Cardiovascular support may extend life, while neural or muscular decline continues independently. Longevity increases, but coherence does not. The modern environment does not cause uneven aging. It stretches time and fragments signals, allowing ancient differences to express themselves fully. Each system continues to respond according to its evolutionary design, but without the shared pressures that once aligned them, uneven aging becomes more pronounced, not because humans are failing biologically, but because they are surviving biologically far longer than expected. The final axis begins by shifting our attention away from the body itself and toward the world the body now lives in. Until this point, uneven aging has been explained as an internal legacy of evolution. Separate systems, separate timelines, separate priorities. But those differences do not unfold in isolation. They interact continuously with the environment. And in the modern world, that interaction has become uneven as well. The human body did not simply evolve to age at different speeds. It evolved to age at different speeds under very specific conditions. When those conditions change, the gaps between systems widen. Modern life does not rewrite our biology, but it removes the buffers that once softened its consequences. For most of human history, physical effort was unavoidable. Movement synchronized muscles, bones, metabolism, and circulation through shared demand. Today, effort is optional. Muscles lose stimulation long before the brain does. Bone remodeling slows, while cognitive load increases. These systems drift apart not because one fails, but because the signals that once aligned them no longer arrive together. The body follows its rules faithfully, but the rules are being triggered out of sequence. Time itself begins to feel uneven inside the organism. The same mismatch appears in energy use. Early humans lived with scarcity and unpredictability. Metabolic systems evolved to expect fluctuation. In modern environments, food availability is constant. The body responds as designed, storing energy efficiently and signaling abundance. But not all tissues interpret abundance the same way. Blood vessels, connective tissue, and immune systems accumulate long-term strain, while other systems continue functioning smoothly. Aging accelerates where excess becomes costly and slows where stability is maintained. This is not a failure of regulation. It is regulation operating without the context it evolved to expect. Sleep offers another example. Sleep once followed environmental cycles closely. Darkness, fatigue, and safety aligned rest across systems. Today, artificial light and irregular schedules fragment those signals. The brain adapts behaviorally, maintaining alertness and function. The body absorbs the physiological cost unevenly. Hormonal rhythms shift. Repair windows shorten. Some tissues recover, others fall behind. Aging becomes staggered, not because sleep is lost, but because its coordinating role is weakened. Medicine further exposes this structure. Modern care often preserves one system at a time. The heart is supported, joints are replaced, pain is reduced, vision is corrected. Each intervention extends a local timeline without resetting the others. Life lengthens, but integration does not. The body survives longer while remaining internally unsynchronized. What once ended quickly now unfolds slowly, revealing every mismatch. Uneven aging becomes more visible precisely because decline is postponed. This creates a new experience of time inside the body. One part continues, another slows, another adapts, another resists. The sensation of imbalance is not the body losing control. It is the body revealing its true architecture under extended lifespan. Modern humans often interpret this as something going wrong, but nothing new is breaking. What is happening is exposure. Ancient biology is being asked to perform under conditions it was never shaped to manage. Aging feels uneven because the body was never designed to age together in a world where survival could be prolonged indefinitely. This final axis does not resolve that tension. It simply makes it visible. To live long is to live inside a system whose parts were never meant to agree on time. And that raises the quiet question that remains open. If uneven aging is not a flaw, but a consequence of survival itself, what does it mean to care for a body that was never designed to grow old as one? If uneven aging becomes more visible in modern life, it is because time itself has changed meaning for the human body. For most of human history, time was compressed by uncertainty. Life unfolded under constant risk, and the future rarely extended far beyond immediate survival. In that context, the body's separate aging clocks rarely conflicted. Systems declined at different rates, but life usually ended before those differences could fully separate experience. Today, time stretches. Survival is no longer the limiting factor. This exposes a deeper truth. The body does not experience aging as one continuous process, but as a sequence of overlapping endings that arrive at different moments. Each system reaches its limit according to its own logic, not according to the needs of the whole. This creates a psychological dimension to uneven aging that early humans rarely faced. Modern humans are conscious of decline while still capable, reflective, and aware. One part of the self still plans, hopes, and remembers. It emerges naturally when systems designed for different lifespans are forced to coexist longer than expected. Evolution never selected for internal coherence across extended time. It selected for competence within narrow windows. When those windows close at different speeds, the sense of imbalance appears. Importantly, this imbalance is not just physical. It shapes identity. Early humans transitioned roles as physical ability changed, but those transitions were embedded in social structures. Modern individuals often experience decline privately, without clear social markers. The body changes unevenly, and meaning struggles to keep pace. The nervous system continues to evaluate the future, while physical systems signal limits. This creates tension not because the body is failing, but because awareness now outlives strength. The body did not evolve to carry long-term self-observation alongside decline. That capacity arrived later, as cognition and social complexity increased. Uneven aging, therefore, becomes something we notice, reflect on, and worry about, even though it has always existed. Another layer of this experience comes from comparison. In early human groups, aging was shared. Differences existed, but survival pressures were common. Today, medical support, lifestyle, and environment vary widely. Even within one body, different systems receive different levels of attention. Exercise supports muscles and circulation. Cognitive engagement supports certain neural functions. Nutrition affects metabolism more than connective tissue. Care becomes selective, not because of neglect, but because interventions target specific systems. This selectivity mirrors the body's own uneven design. Aging becomes something managed in parts rather than experienced as a whole. The result is a prolonged awareness of difference. We feel young in one way and old in another, capable in one domain and limited in another. This fragmentation can feel like loss, but it is better understood as prolonged exposure to transitions that once passed quickly. The human body was never meant to linger in between states. It was meant to move through them or not reach them at all. Modern life holds us in these in-between spaces. Uneven aging is the cost of that pause. It reveals not just biological design, but the emotional consequences of living beyond evolutionary expectation. The body does not tell one story of aging. It tells many, unfolding at once. And the longer we live, the more clearly we hear them diverge. This prepares the ground for the final movement, where the question is no longer why aging is uneven, but how humans respond to that unevenness when no natural resolution arrives. The final movement does not attempt to correct uneven aging, because correction was never part of the body's design. Instead, it asks how humans live inside this reality once they understand it. When we stop expecting the body to age as one, the experience of decline changes shape. Aging becomes less about loss of balance and more about negotiation between systems that were never meant to agree. The human body does not fail all at once because it was never built to succeed all at once. It was assembled to survive, moment by moment, system by system. Living long simply makes that assembly visible. This understanding removes a quiet burden many people carry, the belief that something has gone wrong because different parts of the self feel out of sync. Uneven aging is not evidence of personal failure or biological mistake. It is the normal expression of a body continuing to follow ancient instructions in extended time. From this perspective, Care does not mean forcing harmony where none exists. It means learning which systems respond to which signals and respecting their limits without demanding uniformity. Movement supports tissues that evolve to expect it. Rest protects systems that fatigue slowly. Learning and reflection nourish neural circuits shaped for experience rather than speed. None of these actions restore balance across the whole body. They simply allow each part to operate within the logic it was given. This reframes aging as stewardship rather than repair. The goal is not to keep everything young together, but to prevent unnecessary acceleration where it is avoidable. Even this approach has limits. No amount of care can fully synchronize clocks that were never connected. But understanding those clocks reduces confusion. It replaces frustration with clarity. The body is not betraying itself. It is expressing history. This insight also carries a broader lesson. Human expectations of aging are cultural as much as biological. Modern societies often imagine decline as a single downward slope. When reality refuses to follow that shape, discomfort arises. But the body is telling a more complex story. It ages in layers, revealing which functions were meant to last and which were meant to pass. In earlier human groups, this layered aging had meaning. Physical strength gave way to knowledge. Speed gave way to judgment. Roles shifted as systems changed. Uneven aging did not isolate individuals. It redistributed their place within the group. Today, those transitions are less clearly marked. The biology remains, but the social structures that once absorbed it have weakened. Understanding uneven aging, therefore, invites a reconsideration not only of the body, but of how humans value different stages of life. The body's design suggests that aging was never meant to be uniform, but it was meant to be shared. When lived alone, unevenness feels like imbalance. When lived within continuity, it becomes transition. This does not eliminate loss. It changes how loss is interpreted. Aging, then, is not a single journey moving steadily toward an end. It is a series of overlapping journeys, each reaching its limit at a different time. Some end quietly, some transform, some persist longer than expected. The human experience of aging emerges from their interaction. To understand this is not to solve aging, but to see it clearly. And clarity itself carries value. It allows the final question to remain open, without fear or denial. If the human body was never meant to age as one, and if uneven aging is the natural outcome of survival rather than a flaw, then what would it mean to build a life that honors each system as it changes, without demanding that they all move through time together?